Welcome to this video on OWASP Top 10 Security Risk. In this video, we are going to continue our conversation about source code level vulnerabilities and risk according to the OWASP Top 10. Now again, the OWASP Top 10 is related more towards the web application security risk, but they greatly translate over to software and certainly at the source code level. And that's why we are focused on them. And again, in the previous video, I talked about the 2017 version and the 2021 version. In this video, we are going to continue the conversation about the 2017 version. And then I will address the 2021 version in the next video. So let's pick up the conversation and let's talk about number 6, the top 10. Now we are talking about number 6, which is security misconfiguration. Now, this risk is caused by unpatched software default accounts and the overall lack of hardening that's going to increase the attack surface. Unpatched software increase the attack surface, default account that have not had the password reset that increase the attack surface, and then the overall lack of hardening according to security controls or industry best practices or what have you. It's just going to increase your chance of being attacked and being compromised. So we wanna follow those industry best practices or regulation to properly secure our software and test and assess regularly. We also want to minimize the attack surface by disabling anything that's not required, any software, any functionality, any services, things like that. And we want to regularly test and assess that software to make sure that it's compliant with organizational governance and it also meet industry best practices as well. So this one pretty straightforward, and that take us to the number 7, which is a cross-site scripting. This occurs when an unauthorized script or unauthorized code is injected into a web page and then it is executed in victim's web browser. So this is a browser side injection attack. We talked about injection. That was the very first top 10 risk we talked about in the previous video. This is form of an injection attack. This attack is always executed in the web browser. The idea is to trick the web browser and take advantages of the trust that the browser has with the web server. Now, there are 3 ways that this can be done: the stored, reflected, and DOM base. Now, stored cross-site scripting occurs when the injection script code is stored on the targeted server. So an attacker stored the script on the server and then trick a user into executing it in their web browser. And then we have a reflected cross-site scripting attack, which occurred when a malicious script comes from the victim hypertext transfer protocol or HTTP request. Then we have document object model or DOM cross-site scripting, which occurs when the DOM environment is modified to execute the injected code. Now I am gonna show you an example of how this works. Just a very simple example, but let me explain what reflected and DOM mean. Reflected just mean response, like a reflection in the mirror. It's similar to an echo command or a print command in coding. Think of the message being shown to you on the screen. That's reflection. In other words, when the victim makes a request to view a web page, the web page will return a script that's embedded in the URL in the web browser in that link. And if the victim clicks on that link, then the script will be activated. So they display a message. There is a link, hey, click on this link, you need to upgrade your password. Or maybe, hey, we received your request, click here to claim your free gift or whatever. And boom, that will execute the script. Now, there's another version of this called blind cross-site scripting. And this occur when the code is stored and then it is reflected back to the victim. But the attacker has no idea of knowing that it was successful or not. So that's blind, meaning they can't see what happened. Then there is a DOM cross-site scripting attack. This is more of focused on an API interface, an application programming interface. This is focused on how the programs and script dynamically access and update content. This also has to do with the structure and style of the XML format or even the HTML format as well. So by getting a user to click on a link or otherwise accept a change, the injected code can be executed and that will allow the cross-site attack to be completed. Let me give you an example of how this works. This is a stored cross-site scripting attack where the attacker will store the script on the web server. They either inject it through the website or maybe they just have a backdoor to the web server and put it on the server. Either way, the script is on the server. When a client goes to connect to the website, in this case the victim is going to connect to the website, they are gonna request some kind of data from this website. They want to see a product, they want to see a library, they want to see something, they wanna see all the different shirt or pants, or they wanna see cool coffee cups, whatever it is. All of a sudden an error message is going pop up and state, oh, an error happened. Click here to continue. In that link, the script is now called and activated because it's going to use the trusted connection that's already been established between the victim and the web server through the website. And then the script executed the injected code, whatever it might be. And in this case, maybe we are trying to collect some data. So now the attacker will receive the data. So the stored cross-site scripting is when the script is on the web server. The reflected is when we show the message and ask the victim to collect it. So maybe the stored cross-site scripting, maybe we just have a logic bomb or something set up where it activates when a certain user on the site. Not a big deal. But now we have an arrow that pops up and we get them to click it, and that's the reflected attack. So again, that reflected cross-site scripting is when the victim clicks on the link, and the actual DOM cross-site scripting can be carried out this way as well, except the malicious script will now modify the XML or the HTML environment. So that's simple example. Now to defend against this, we want to use modern scripting language that provide escape sequence. So we talked about that with the injection attack. So again, cross-site scripting is a form of an injection attack. So we want those escape sequence built in for untrusted data. So we want to use things like Ruby, React Native, Java, things like that. And also we want to implement content security policy into the HTML code of the web page. Now this is a hard-coded directive or instruction for the code, and it will authorize specific action within the web page and deny everything else. So how many times have I said permit by exception and denied by default? That's exactly what the CISSP is designed to do for HTML. That takes us to number 8, which is insecure desterialization. Sterilization is process of converting the data format of an object that's typically used for communication or storage. So we are converting the format, we are sterilizing the format. Desterializing reverse this process to reuse the converted object. Now, according to the OWASP, this is most used for JavaScript object notation or JSON. So this can be accomplished again XML, Python and other language as well. Now for the exam, you don't need to know all of this. What's important to understand is a software is converted to and form object to machine language and so on. We want to have control of that if possible. In the developed code, This actual risk focuses on the aspect. The most important aspect to understand here is the XML eternal entity, and we already talked about that as a risk as well. For this particular risk, we want to implement digital certificates or mutual authentication for critical applications that perform sterilization. We also want sandbox or isolate the code that deserialize to prevent exposure of the critical application. And we also want to restrict connectivity to critical application that perform sterilization. So the bottom line for this one here is just to understand that we want to only execute API connection and other connection with software that we trust. We don't want to allow untrusted connection, then that's going to reduce the risk that much further. Then we can focus on sandboxing and isolating the code as such. That takes us to the number 9, which is the component with vulnerabilities. This is pretty straightforward. This is caused by using components with known vulnerabilities, which is going to increase the risk of exploitation. So what we want to do here is clearly identify the known vulnerabilities, continuously monitor them, and apply compensating control where needed. So we wanna research those vulnerabilities with somewhere like the National Vulnerability Database. We wanna look at common vulnerabilities and exposure, CVEs. We also want to research vulnerabilities on the vendor's website. This might seem obvious that we should not be doing this, but a lot of legacy application and the legacy hardware have to be used for certain systems that are just older. They are running older application, they are running older operating system, they are known to have vulnerabilities, but because of the operating state they are necessary. And this is what we are talking about with this particular risk. Wherever possible we want to patch, we want to apply compensating control and so on. And also if the vulnerability is critical or a high risk, we want to consider maybe discontinuing the use of this and moving to a newer application if possible. That takes us to number 10, which is insufficient login and monitoring. Again, another straightforward one. This can prevent the discovery of threats, vulnerabilities, and attack against software applications. So we want to log all changes to critical system services, all changes to privilege level, accounts, communication, and more. And again, we focus on this in the login and monitoring video. The bottom line for this video is to understand this OWASP security risk and the mitigation for the exam.